Okay guys, in this video we're going to be taking a look at our natural exponential functions. That is to say that, an exponential function, of course, is any function of this form. At least the parent function is of that form. Our transformations, of course, are this form right here. But that is to say that our base could be anything. In this particular video, we're going to be taking a look at a very special base. We're going to say that base is e. And so e, let's give it a few names here. We say, first of all, e is the natural base. Okay, so when you say it's the natural base, then people know what you mean. They know you mean e. And then also this, e is a number, and what I want to do is find this number. So in order to find this, what I'm going to have you do is on your calculator, look for this little button that says ln. This actually stands for the natural log, and right behind it what you're going to see is e to the power of x. And so before we talk about our natural log, we talk about our natural base, and in order to get this, you're going to have to, let me get out of this menu here. We're going to have to type in e to the power of by typing in second ln. And what it says is, okay, well, what do you want to know? Well, I just want to know what e is, e to the first power. And what I expect is that everybody knows that e is approximately 2.718-ish. And so we say it's a number, and it's about 2.718-ish. And so when we look at this exponential function right here, what we're really saying is y equals about 2.718 to the x. And that's all we're really talking about right here for our parent natural exponential function. So what I want to do is actually start by making a graph of our parent natural exponential function. And so I can see here that it would just be y equals e to the x with an a value of 1 and h and k would be 0 and 0. So because this is the parent, we're going to do what we do with all parent functions when we sketch them in terms of an exponential function. We're going to plug in 0 and 1 for our x values and table those. And we're also going to recognize that there is a horizontal asymptote at the x-axis here. And so we would say y equals 0 will be our horizontal asymptote. And we say when you plug in 0, well, I suppose we get e to the 0. Now, what do you know about anything to the 0 power? Well, I know that anything to the 0 power is 1, so when I do e to the 0 power, I should get 1. And so I get 1. And the neat thing about this is when I plug in 1, I get e to the first, which is just e, which I'm going to write e, but then I'm also going to write as about 2.718. So that when I go over here and I graph this, I actually know where e lies. So we say 0, 1. I totally expected this to be on the parent function anyways. And then 1 comma e, which would be just, about 3/4 of the way between 2 and 3 here. We would say that this is our parent natural exponential function. And it looks like every other exponential function except for the base is just specifically 2.718, 2818, 28, blah, 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 blah. So what we're going to do is we're going to use this function here. Now, I haven't labeled these points on my graph, but I did table them. But in order to graph something like, for instance here, e to the x plus 2 plus 3. And so instantly what I recognize is that our h value here is actually negative 2, and our k value here is a positive 3. It's going to take everything on our original parent function here and shift it 2 to the left, 3 up. So the first thing I'm going to do is I'm actually going to grab the asymptote, and I'm going to shift it up 3 into the air. So we would say that it is at a height of y equals 3, or at least that's its equation. And in terms of these 2 points that we saw occurring on our natural exponential function, we'd say 0, 1. If I were to go left 2 and up 3, instead of 0, 1, I go left 2, up 3, it would be located here at negative 2 comma, and I suppose if we were initially at a height of 1, we went up 3, we went at 4. That would be our new height. So we say 2 comma 4 would be this point right here. And then our other point on here, well, we had 1 comma e. And so what we're doing is we're shifting this left 2, up 3. So to go left 2, up 3 from 1 comma e. 1 comma e was about right here. We'll go left 2, up 3. You could see that it would lie in this general neighborhood. But what I want everybody to recognize is that if we were to go left 2 from 1, okay, we would be at an x value of negative 1. And if we were to go up 3 from e, we could see that we'd be at e plus 3. And it is acceptable to write negative 1 comma 3.718. And what I mean by that, or sorry, 5.718. 5, that's a 5, guys. Because what we're doing is we're taking that initial 2.718 and just really adding 3 onto it. So whether you want to give me the exact value or the decimal, what I would expect to see is that because we can graph our parent natural exponential function, then we can just graph any transformation of that as well. Cheers.